with this problem here, this was to be today's exit ticket. Today is 10/23. A farmer wants to create an enclosed area along a river to grow some crops. He only has 900 feet of fencing to do it. Should the area be in order to maximize the square feet of crops? All right, so farmer wanted to grow some crops. We got this little diagram down here that's going to help us out. We have 900 feet of fencing to do it. Well, this kind of seems like a system of equations. It's really just going to be a single quadratic that we're going to be finding the vertex of. We'll see that in a second. So we get our one side for free, that's the river. And then we make up our area with two sides that have the same length. We'll call those X and X. And one side length that's different to those two side lengths, we'll call that Y. The first thing I'm going to do is I want to express Y in terms of X. So let's express Y in terms of X. So I know that, I'll write it like this. I know that X plus Y needs to be equal to 900. All right, because that is the total length of our fence. So there's an X here, an X here, and a Y, and together they need to be equal to 900. Combine my like terms, this becomes 2x plus y equals 900. Subtract 2x from both sides. And I get that y equals negative 2x plus 900. So there, I've expressed y in terms of x. So now in my diagram, it could be a rectangle like this with dimensions x and negative 2x plus 900. All right, let's plug that into our area formula. The area of a rectangle is equal to length times width. In this scenario here, area is going to be equal to x times negative 2x plus 900. And after I distribute that x, we get that the area is equal to negative 2x squared plus 900x. So this is going to create a parabola. We could even sketch a quick parabola of this. When x is 0, we're going to have 0 area because it'll be flat. And then when x is 450, we'll have 0 area again because it'll be flattened in the other direction. We got to find this vertex here. The vertex is going to maximize our area. So the vertex maximizes area. So we need to find the vertex. One strategy for finding that vertex is converting this to vertex form. So first step of vertex form is to divide everything by any a value that we have. So I'm dividing everything by negative 2. We get a over negative 2 equals x squared minus 450x. Now I'm going to keep going with this. Area over negative 2 equals x something squared. There's no c term to keep here. That something is always 1/2 of this value here. So we divide that by 2. This is x minus 225. And then we need to subtract away the extra. So x minus 225 times x minus 225. That's going to get us an x squared minus 450x. But the extra here is 225 squared, which is 50,625. So let's subtract that away. Subtract 50,625. And the last step of finding vertex form here, we send that negative 2 back by multiplying everything by negative 2. And so now we get that area equals -2 x minus 225 plus this number times 2, 101,250. So looking at vertex form here, our vertex is at 225, comma, 101,250, just based on this vertex here. So that is the vertex, and that tells us this. All right. The width of the farm should be 225 feet. This will give us 101,250 square feet of farmland. The only thing missing is the length of this area here. But we've got this expression. We already figured out y in terms of x. So we'll just use that expression, -2x plus 900. So if y equals -2x plus 900, y is going to equal -2 times 225 plus 900. Y equals -450 plus 900. Y equals 450. So the length would be 450 feet. All right, so that's how we solve this problem here. The whole thing altogether is right there. All right, so a very similar problem coming up on the unit test, and I will see you in class.